Does crushed ice lower water temperature more than solid ice? By Alexander Gorbeth and Wazy Song. We always believed that crushed ice would have to be a different amount of change in temperature than solid ice. Because of the smaller the ice is, we thought the bigger the change in temperature, and the faster it would be. But we will see later on, through our question of interest, is there a difference in average water temperature change between solid ice and crushed ice? And our parameter of interest, which is the difference in mean final water temperature after 5 minutes for cups of solid ice and cups with crushed ice. And how we collected our data was we went to a local supermarket and then we picked out a bag of ice that was randomly selected out of the freezer. We used a random number generator out of the total ice bags that were there, and after we did a random selection, we chose this 15th bag. And to limit confounding variables, we chose 40 cups, and we all had the same amount of water in there, 200 milliliters. And all the ice that was added, no matter if it was crushed ice or solid ice, was 20 milliliters. As well as another confounding variable that we have seen and we accounted for was temperature and time. So we did the constant 5 minutes, and we kept it inside the same room during the same time frame in order to limit any other confounding variables that may be seen. We wish to test the following hypothesis at the 0.05 significance level, where our null hypothesis is the mean difference in temperature for solid ice is equal to the mean difference in temperature for crushed ice. And our alternative hypothesis is that there is a difference in the mean difference in temperature for solid ice and the mean difference in temperature for crushed ice. In order to do a confidence interval and hypothesis test, we have to test normality. And to test normality, we looked at two dot plots side to side to see if they're both symmetric or there's obvious outliers. And in both of them, there could be seen some slight outliers, but I would say it's mostly symmetric with no super big outliers, in that we can assume normality inside both of these graphs, as well as we have to check 10%. And we can assume that there's more than 10 bags of ice in the world. We 100% know that there is, but we just have to assume. And then randomization, we randomly selected our bag of ice through the process of randomly selecting it inside the freezer and inside our local store. And in order to do the t-interval and confidence interval, we did 5 steps. Calculated the difference in temperatures for means after 5 minutes for each set of data, solid ice and crushed ice. We calculate the means of each set of data. We calculate their standard deviation. And we use the 2-sample t-test to solve for t and p, which would be negative 1.13 and 0.26 for p. As well as we use the mean, the standard deviation, and a t-star for 19 as our degree of freedom. And our confidence interval would be negative 1.83 to 0.53 degrees of change. Well, in conclusion, we will fail to reject at the significance level of 0.5 due to our p-value of 0.26. We have convincing evidence that there is no significant change in difference in temperature between solid ice and crushed ice of 20 milliliters in a 200 milliliter cup in room temperature. Since 0 is contained in our 95% confidence interval of negative 1.83 to 0.53, there is no significant difference in mean change in temperature between solid ice and crushed ice. We can see that there is no difference in change in temperature, even though we generally believe that crushed ice will have a greater change in temperature for cups of ice. And if I ever did this project again, I would think of doing more tests with different shapes of time, like maybe 1 minute, 2 minutes, to see if there's a difference in temperature that is more rapid that we could assume that there would be for crushed ice, but we just weren't sure exactly with a 5-minute timer that it might have been just too long to see that true difference in between the different types of ice. And thank you for listening.